Hello everyone, I am Pushpender Singh, entry number 2024 CYS 70226. Today I am going to present my presentation on X-ray generation, reference taken from Georgi S. Girolami X-ray crystallography. In this part I will discuss about the introduction, what is X-ray, source of X-ray generation, physics behind X-ray, type of radiation source, what is filter, monochromator and synchrotron sources. So first I will discuss about introduction part. What is X-ray? So X-ray were discovered by German physicist Wilhelm Röntgen in 1895. X-rays are electromagnetic radiation like visible light, except their wavelength are order of 1 angstrom and visible light wavelength is in the range of nanometer. That's why these rays are 1000 times shorter than the visible light. And due to shorter wavelength, these are high energy waves and harmful for our body. And these waves are used for imaging and crystallography. Now I will discuss about the source of X-ray generation. So X-ray is generated in laboratory by accelerating electron in an electric field of 1000 volts and then strike them on metal surface. One design for X-ray generator is called X-ray tube or hot cathode tube. This is the diagram of X-ray tube. So we will discuss about what is hot cathode tube or X-ray tube. X-ray tube contains an heated filament that generates the electron that is a negatively charged and it acts as a cathode, and the target that is positively charged anode. When the electron strike the target, X-rays are generated, and at higher voltage high energy X-rays are generated, and at higher current more X-rays are emitted by the anode and X-rays become brighter. But there is one limitation of hot cathode tube is that the target will melt if the current striking the target is too large. One way to overcome this limitation is use of rotating anode in which the target is rotating metal ring. In this design, only a small part of spinning anode is struck by electron beam at one time. After being struck, that part of anode immediately rotates away out of the beam. While it completes a revolution, that part of anode has time to cool off before it re-enters the electron beam. That's how rotating anode tube prevent overheating by disturbing heat and enables higher current or higher brighter X-ray beam. In a conventional hot cathode or rotating anode tube, only X-ray emitted in exactly the right direction pass through the crystal. X-ray emitted by anode in other direction are not used. To obtain a high X-ray beam intensity is to use optics to collect X-ray emitted in many directions by anode and focus them onto the crystal. That is the X-ray generation source. Now I will talk about the physics behind X-ray. So X-ray can be generated via two processes. If I talk about the first process, in the first process, when electron strike the metal target, it get deaccelerated by electrostatic interaction with atom, and light is emitted when a charged particle changes its speed or direction, and as a result the deaccelerated electron radiate X-rays of various energy that can be shown in this diagram, that the incident electron strike the target, that is atom, and it get deaccelerated and emit X-ray. The second process by which the incident electron knock electron out of the core orbital in the atom of metal target, the resulting vacancy in the core orbital are filled by outer shell electron, and this transition leads to emit electromagnetic radiation in the form of X-rays. Now In this diagram we can see that the incident electron ejected electron out of the core orbital and X-ray can be generated. Now we will understand what is this K alpha K beta represent. So I will discuss about interpretation of K alpha and K beta. So KLM represent valence shell, K represent 1s cell, L represent 2s 2p cell. Basically K represent the cell in which principal quantum number is 1, L represent the cell in which principal quantum number is 2, alpha and beta represent which cell supplies the electron. If I talk about K alpha means electron is supplied from 2p cell to 1s cell. If I talk about K beta means electron is supplied from 3p cell to 1s cell. Subscripts 1 2 represent the spin orbital coupling, the coupling between electron spin angular momentum and orbital angular momentum. K alpha 1 represent the electron supplies from 2p 3/2 to 1s, and K alpha 2 represent electron is supplied from 2p half cell to 1s cell. Now I will discuss about the type of radiation source. So there are two type of X-ray radiation source. The first source is copper source. Copper source is longer wavelength source, therefore it absorbed more strongly by the crystals and give diffraction pattern in which beam are spread farther apart, high resolution. Due to this it is used for larger crystal like protein. And the second source is molybdenum source. It is a shorter wavelength source, and due to its shorter wavelength it has low resolution power and it is used to study small unit cell. Now we will discuss about the filter and monochromator. What is filter and monochromator? So first we will understand why we need a filter, why we need to filter the X-rays. So the reason behind it is that the wavelength of K alpha 1 and K alpha 2 lines differ by less than 1%, and this difference is too small to be significant for X-ray diffraction experiment. A beam with both lines behave effectively as monochromatic in X-ray diffraction experiment. On the other hand, K alpha and K beta X-ray wavelength differ by approximate 10%. A beam containing both is not monochromatic. Each wavelength produces separate diffraction pattern, and these patterns can overlap, making it hard to measure accurate intensity. Since K alpha radiation is stronger, X-ray beam are usually filtered to remove K beta lines. This is done by using a absorption filter that absorbs K beta but allows K alpha to pass. And the element used as a filter has its adsorption edge between the K alpha and K beta lines of the target element. And we are using filter based on the following principle is that X-ray generated from target with atomic number Z. A good filter to remove K beta radiation selectively is a foil with atomic number Z-1. For example, copper radiation, a nickel filter is used because its absorption edge lies between copper, K alpha and K beta, and we know copper atomic number has 29 and nickel atomic number is 28. Now we will talk about monochromator. What is monochromator? So there is one way to filter X-ray is using filter, and the another way is you get monochromatic X-ray is use of monochromator. So one another way to X-ray beam to generate X-ray beam containing only K alpha radiation is used to X-ray monochromator. A crystal monochromator can be used to select one wavelength from the X-ray beam by diffraction, and it has a diffraction grating like a prism that separates out all the various wavelengths at different angle. It is then easy to select only those X-rays that diffracts off the grating at a certain angle. The resulting X-ray beam will be monochromatic. and graphite or quartz crystal are commonly employed to get a nearly monochromatic X-ray beam. Now this is the diagram of filter and monochromator. We can clearly see that for copper nickel is a filter that separates K alpha and K beta radiation. Now we will discuss about synchrotron sources. So before studying synchrotron sources, we will study why we need of synchrotron sources. So there are some limitation of conventional X-ray sources. To overcome these limitation, we use synchrotron sources. So what is the limitation of conventional X-ray sources? For very small crystals less than 0.5 mm on the edge, hot cathode X-ray sources are too weak to be used. The diffraction pattern obtained from such small crystal is so weak that little information about the crystal can be obtained. In such cases, it is necessary to use very high intensity X-ray beam so that the diffraction pattern is strong and certain enough useful information to enable the structure to be determined. In addition, for some experiment like solving crystal structure of protein, it is useful to carry out data collection using X-ray of several different wavelengths. For both purposes, X-ray radiation is generated by the synchrotron sources. Now we will discuss about what is synchrotron radiation, the ideal source. So synchrotrons are basically evacuated pipes curved into a large ring that is 10 to 100 of meter in diameter. Electrons are injected into the pipes and accelerated to very high speed. Magnet curve the electron trajectory, and when electrons are accelerated either by changing direction or changing speed, they emit light at velocity close to the speed of light. Accelerated electron emit X-rays, and synchrotron radiation is up to billion times more intense than the radiation from the hot cathode tube. So this is all about the X-rays. There is one synchrotron source, the Advanced Photon Source at Argonne National Laboratory. This is the diagram. So this is all about the X-rays. Thank you very much.